Section 5, question 6. Functions f and g are defined by f of x equals x squared plus 3, g of x is x plus 4. First of all, find f of g of x. So f of g of x is f of x plus 4. The f function is whatever's in the bracket, write it down, square it and add on 3. So whatever's in the bracket, write it down, square it and add on 3. So if I open that up, that'll be x squared plus 8x plus 16 plus 3, x squared plus 8x plus 19. Then I'm looking for g of f of x. So g of f of x is g of x squared plus 3. And we can see that the g function is whatever's in the bracket, write it down and add on 4. So whatever's in the bracket, write it down and add on 4. That's x squared plus 7. The question then says, show that f of g of x plus g of f of x equals 0 has no real roots. So I'm just going to add both these things together and then look at the discriminant. So x squared plus x squared is 2x squared plus 8x plus 26, and that's equal to 0. And I'm looking to show that we've got no real roots here, so show means I'm going to back it up with a statement to communicate what's going on. So a is equal to 2, b is equal to 8, and c is equal to 26, and b squared minus 4ac. And let's just investigate this result. So it's going to be 8 squared minus 4 times 2 times 26. So 8 squared is 64, and take away 8 times 26. So I'll just come across here and do 26 times 8. 6 8s are 48, 8 down carry 4, 8 2s are 16, plus 4 is 208. So I'll get 64, take away 208. And that'll give me minus 144. So the discriminant is less than 0, so I would say that d equals minus 144. Minus 144 less than 0. Therefore, roots are non-real. Section 5, question 7. Prove that the roots of the equation 2x squared plus px minus 3 equals 0 are real for all values of p. The condition for roots being real is that the discriminant is greater than or equal to 0. So we need to prove that that's the case for this particular function. So I'm going to first of all get my coefficients. So I've got a is 2, b is equal to p, and c is equal to minus 3. If I then put that stuff into the discriminant, so that will be p squared minus 4 times a, which is 2, times c, which is minus 3. And that will be p squared minus 4 times 2 is minus 8, times that by minus 3, and that will be plus 24. Now, since p squared can never be negative, the least possible value for that is 0. So for the full discriminant, the least possible value is 24. So the key thing really though is that we can say that the discriminant is greater than 0, which is part of a condition of greater than or equal to 0. So it's greater than 0. So p squared plus 24 is greater than 0. Therefore, the roots are real for all values of p. And that's the end of the question. Section 5, question 9. For what value of k does the equation x squared minus 5x plus k plus 6 have equal roots? So the condition for equal roots is that the discriminant is equal to 0. So I'm going to identify a and b and c. A is 1, b is minus 5, and c is everything else, and that's k plus 6. So I'm going to sub that in. So minus 5 squared minus 4 times a, which is 1, times c, which is k plus 6, is equal to 0. Minus 5 squared is 25, and minus 4 bracket k plus 6 is equal to 0. So that's 25 minus 4k minus 24 is equal to 0. So it's minus 4k plus 1 is equal to 0. Minus 4k is equal to minus 1. And k is equal to minus 1 over minus 4. And that's 1/4, and that's the final answer. Section 5, question 10. The diagram shows part of the graph of a quadratic function y equals f of x. The graph has an equation of the form k bracket x minus a bracket x minus b. What is the equation of the graph a, b, c or d? Well, we can see that there's a root at 1 and 4, and we pass through the y-axis at 12. Well, I know that a root of 1 comes from a bracket of x minus 1, and the root of 4 comes from the bracket x minus 4. In terms of the value in front, I'm not sure of that just now, so I put a proviso in front, which is k. I then use this point in the question to help me proceed, and this point is 0, 12. So the x coordinate is 0, and the y coordinate is 12. So wherever I see y, I'll replace it with 12. And where I see x, I'll replace it with 0. So now I've got 0 minus 1 times 0 minus 4. So minus 1 times minus 4 is 4. So that means that we've got 12 equals 4k. And k is equal to 12 over 4, which is 3. So the final answer is y equals 3 bracket x minus 1 bracket x minus 4. And that is option A.